So yesterday we were discussing that how to conceptualize the system, CPS based system. So let me show something and then I will discuss it. So when we are conceptualizing the CPS, basically we have to see that what will be the components which we require. For example, this is the architectural components of CPS proposed in this paper published in Sensors in 2021. So we have the data. This data may be recorded by the sensors. So whatever physical system we are having, we are trying to gather the information related to that data. For example, yesterday when we were discussing a healthcare system. So let me show you that. So yesterday we were discussing the healthcare system. And then when we are talking about the healthcare, cyber physical based healthcare system. So first thing was that the data was related to the patient. Okay? So first data we require is the patient information. So the patient will be given certain identification number, some number, and that identification number can be you can fetch that information from the barcode, which is printed on the prescription or the hospital receipt. Because in CPS, basically, we are trying to make the system contactless. So we may be having the hospital receipt, which is having a barcode number printed on that, and then when the patient goes to some doctor or some outdoor clinic, there he will show this receipt, and the reception there, they will scan the barcode. So from the barcode, the information related to the patient will be gathered. It may be the name of the person, what is the age, some basic information of the patient, and it can be done, right? Instead of barcode, you can use the some face recognition system, or biometric. So through the thumb impression or through the face recognition system, the same information can be collected. So maybe the reception there, it will be having a camera. So there in front of the camera, when the patient goes, the face will be recognized, and then from the database, it can be phased out, the information can be phased out, right? It may happen that the patient may be coming back, right? So in that case, if it is a repeat case, so whatever is the previous history of the patient, that can also be phased at this stage. So we require certain sensors, and from these sensors, we will be getting some data. In this case, the data is patient information, right? But when the patient goes to the pathology lab, the data may be different, basically, that what type of test to be performed. So from the receipt itself, it can be identified, or the doctor has prescribed some test, maybe the blood test, urine test, or some other X-ray, So that can be phased out information. So you get the sensors. You require the sensors for this, right? If we talk about the manufacturing systems, because most of you are from the mechanical background, so we can say that I have to perform certain tasks on a job piece. So I can identify that particular job piece by the barcode, or it can be a QR code, or nowadays RFID is another way you can get the information about the system. So that will be recognizing the manufacturing process or manufacturing component which is there, right? Now, once the sensor collects the data, it is to be sent, it is to be transferred, right? So for that, you require the network and communication. So there are various protocols which has been developed, communication protocols, and with this, previously actually when we talk about the connecting to network, we consider the internet is the one of the very common example. When internet initially started, there was only the LAN connection, or we say that the PCs were connected through a LAN connections. Before that, there was basically the ring type of system in which the number of PCs were connected together, right? So these internet, whether it will be the LAN system, it can be the other network systems, right? WAN, LAN, WAN, main, and then global internet. So which type of system is required? It depends upon what is the distance between the two communicating devices. If the distance is small, we can go for LAN. Maybe 10 to 20 meters, LAN is fine. If distance is slightly more, we can go for the WAN, wide area network. So it can be that in a whole premises, for example, the institute, IIIT DM Jabalpur, if we consider that, the whole area, if we consider, then it is the WAN, which will be required. Then you have the main metro area network. So it can be the whole city if we want to cover, then you can go for the main. And then if we want to cover the whole globe, we have to go for the internet, basically. So networking is required. In addition to networking, we have to follow certain communication protocols, because if I'm talking in English, most of you are able to understand it. If Professor Imre, he talks in his own native language, we are not able to understand. So that means when two devices are communicating with each other, they have to talk in such a way that both of them, they can understand each other's language, right? So you require certain standard to be followed for such communications, right? So there are a number of communication systems which has been developed over the time, and now the focus is basically that when we are talking about the cyber physical system, so the focus is towards the low power communication systems. So you can have the Wi-Fi, you can have the Zigbee standard, you can have other standards, wireless HART, and other several standards or communications are devices. So you have to collect that information, that how the communication will be happening. And from there, the information which is collected through the sensors, it will, through the network and communication device, it will be transferred to the cloud. So we have to store this data. So at this stage, it is the cloud which is coming into picture. So we can store the data. We can analyze the data. So at this stage, you will be having the data storage as well as the analysis also. Analysis may also be done at this level also. When we are collecting the information from the sensors, we can do some signal processing also. So you require devices for the signal processing also. Right? So data storage, cloud, that comes into picture at this stage. And then we need to take certain action. So actuator is coming into picture, right? And again, this is a cycle, so it will go. So this is a architecture which is proposed in this paper, and it can be applicable to most of the CPS devices, right? This is another way to represent the same systems. You have the physical space, like a car is there, some buildings are there, a home is there, or some persons are there. So all of them, they will be transferring some information. This symbol indicates that there is a transfer of the information. So this information can be transferred through the mobile phone. It can be your smartwatch. It can be some other devices, tab and other devices, computer, right? And so this is the connection level, ICT level basically, right? And then it goes to the cyberspace. So in cyberspace, first we have the networking components. So it can be the router. This is a wireless router. You can see the symbol here. It can be the internet, basically these towers. So the internet we are getting, it is through the satellite communication and then through towers. So that is there. Or you can have some other GSM based system or other systems. So that is there. So that is the networking. And finally, it goes to the cyberspace and computing devices. And this is a typical cyber physical system for the medical systems. So you can see here that this is the personal space. So if you, here you can see the dress which the patient, if the patient is admitted in the hospital, this dress may also be having certain systems embedded with that, so that the information related to patients can be transferred. We can have some systems which may be recording the heartbeat, which can be recording the temperature of the patients, right? Or you can have the smartwatch. Nowadays, smartwatch is having your measurement for the pulsage. They have the BP measurement devices. You can have some other smart watches which may include some other external devices like a measurement of the glucose level for diabetic patients. So all this is the sensors or the physical level. Then there is a cyberspace, which includes the 4G, 5G, or whatever technology is there, hubs, servers, computers. Certain firewalls, etc. Right? And then they are connected to the real space, which includes the patients, care providers, means it can be doctor, it can be nurse, or right. And there may be some other environmental space like what is the temperature outside, what is the humidity outside, it can be, right? So all this makes a total cyber physical systems. These are some of the applications of the CPS which has been proposed in this paper. So that includes the manufacturing. So in the manufacturing, you can have the automated manufacturing process to optimize the productivity of goods. and enhancement of delivery of services. In healthcare, smart healthcare systems are designed for real-time monitoring of patients and support remote healthcare services using semi-automatic medical devices. You can have applications in the transportation. So a smart transportation system in a smart city uses embedded sensors for real-time information sharing. So for example, the train, we get nowadays, we can easily get the information that how much time it will take to reach to the particular station. Previously, such informations were not available, so you have to wait on the platform for number of hours if train is late. But nowadays, you have on your mobile, you can easily get the information, what is the last location of the train, and accordingly, you can plan that when to reach to the platform and board the train. Right? Similarly, you can manage the traffic. Right? Advanced sensing, communication, control, etc. Right? For the autonomous vehicles. In the energy field, you can have the integration of cyber and physical systems to provide a reliable, safe, and secure supply of energy. So the power we are getting, it is reliable, it is safe and secure. So we are talking about the smart grids nowadays. Then infrastructure level, the use of sensors in buildings helps to minimize the overall cost of functioning by optimizing the processes. Right? Similarly, you have applications in agriculture, education. Education, we are using this Zoom link. So it is another example of the CPS basically. Businesses, environment monitoring, security, home, etc. Number of examples are there. So you can refer this paper for more information about this, right? So that was actually to cover up the last practical case. If you have any questions, you can ask me.
No, sir.
Okay. So if you don't have any questions, so what the topic for the today's practice session is the software tools basically, right? So what softwares can be used in this, right? So what I do is that again, just like yesterday, I can divide you into the rooms, breakout rooms. Maybe today the number of participants are only 15, so we can divide it into 3 rooms. What you can do is you can go to the internet, you will try to find out what are the CPS based tools available for planning the CPS. I had already given you the architecture, so it can be the sensors, data communication, it can be the cloud, and how to integrate all of them, right? So you can just search for 10 minutes in this, in your rooms, and then we will again meet in the main room and we will discuss further on that, right? So just I am dividing you into the breakout rooms. You can go to the rooms and then you can discuss tools, and then further we will be discussing in the tool, right? So I am creating the rooms now. It is automatically assigned by the system, right? So 3 rooms are created. You can move to the rooms and then start discussing. You can search the internet and then Okay, so we are back, I hope. So shall we start with room 1? So, from room 1, who was there? So what tools you have searched on the internet? What are the tools available? Just briefly, if you can tell me, and then we will be further discussing it. Anyone? Room 1, room 2, room 3?
From room 2,
Yeah, Anil.
Sir, we have discussed about this. There are two types of two ways we can do at the system. First is the hardware. For hardware, from hardware we can sense different type of signals using the sensors. For that, we can use Raspberry Pi or sir, Arduino to collect these signals at the hardware level. Then we can use the internet through which we can transmit the signal to the cloud. In the cloud, there are some different type of services which is provided by Google Cloud from Amazon, AWS, or Microsoft Azure to store our data to the cloud, and we can also access the cloud from different sources, from mobiles or at different places from different computers also. Or second way is to do the modeling way. In the modeling way, we can model the system into the MATLAB Simulink. And similarly, we can transfer the data to the cloud through the internet, and save our data to the different services, Amazon AWS or Microsoft Azure. They also provide cloud computing also, so we can also automate our data at what interval we want to collect our data, and also we then do the data processing also.
Okay. Okay. Yeah, that's good. And how to integrate all these data?
Sir,
You tried to search for that?
sir, data integration, we can use Wi-Fi routers to
No, routers are not for the data integration. No? They are only for transferring the data from one place.
That I don't know.
Okay. Anyone else from room 3?
Yes, sir.
Yeah, Vivek.
Yes, sir. Basically, for designing cyber physical systems and for communicating the information for its processing, basically, MATLAB and Simulink are the main tools, and there are different sub tools also for basic individual functions like various toolbars in the main software system, like control system toolbar. I search on the internet that control system toolbox, then communication toolbox, then for signal processing, various signals coming out of the sensor, those are processed with the help of different toolbox called signal processing toolbar. Then, for example, if the data is in image form, or we can say it is visionary data, then computer vision toolbox is also there so as to access and process the data. Then deep learning toolbox for different deep learning processes, statistics, machine learning toolbox. Then again, there are different machine learning toolboxes. For example, supervised, unsupervised, and supervised. Then reinforcement learning. So these are various learning toolboxes so as to process the collected data from the sensor. And then again, there are different tools to process the data. And for communicating the data from the sensors to the again actuator, there are different modules. There are different modules, and there are various IoT platforms also, Internet of Things platform, as discussed by my colleague Anil, like Microsoft Azure and Amazon Web Services, like AWS. There are different company domain IoT platforms also, like IBM is having its own IoT platform. So these are basically the IoT platforms which provide the platform to deploy virtual sensors and create a system that will replicate our actual physical system, which may act as a cyber physical system. So, sir, this was the thing I could only explore on the internet in this time. Thank you, sir.
Anyone else who wants to add something to this? If you, Mitesh, you want to add something? Right.
Sir, from the industry domain, is the cyber physical system empowered by the cloud technology that has a novel approach. In the industry 4.0, as we have seen, the European Commission projected with the partners such as Singer Electronics, SAP, Honeywell, and Microsoft. We are well demonstrated. This point I would like to add from it.
Okay. Okay. Thank you, Mitesh. Right. Anyone else actually? You have something to add? Okay. So Vivek, you had covered basically this MATLAB base. So let me first go to the MATLAB website. I am directly taking you to the MATLAB website. Just a minute. This is the model-based design for embedded control system. There is a white paper which describes it basically how to carry out the system modeling and simulation, then model-based design of the control systems, and accelerating the pace and scope of control-based design. There are videos also which covers this. Right? Then, yeah. I take you. This is the paper which describes this basically. This is the white paper, model-based design for embedded control systems, which is available. I am directly taking you to the website of the MATLAB. So you can see there, they discussed that what is the model-based design, right? Then how the workflow of the model-based design will be there. So you have the integration, you have the implementation, you have the design. So what will happen from the research or requirements? You have to first design. So you have to create the model, you have to create the simulations. Then you need to implement them. So for implementations, you can have the hardware like microcontroller unit. You may be requiring the software like DSP, digital signal processing. If you are working in the domain of the VLSI, then FPGA, ASIC, very low. So these are the softwares which are, and if you want the structural text, that is basically the PLC, programmable logic controls. So when we implement it on the hardware, this programming aspects, for example, microcontroller, you can have the Arduino, you can have the Raspberry Pi, they have their own softwares developed. Similarly, for PLC, the different PLC can be used like ABB or Rexroth or the other. So they have their languages, and then you can easily program them. So whatever models we have developed, we can connect it to the hardware with the help of this implementation. So generally microcontroller unit, you will be using C, C++ or assembly language also. In PLC, there is a structural text, there is a format. And for FPGA and ASIC application, VSDL is there. So through these languages, this programming, you can integrate the system. And then at every stage, you have to test and verify. So this is what is proposed by them is the model-based design in this white paper, right? And then they discussed it here. Basically, a case study has been discussed by them. A number of case studies they discussed. Right? You can go through this paper. Website is on the website. You just search, and then they had discussed what are the different aspects also. So if you see that, so if you write certain code, so how to do that? So it can become the part of the design. So they try to answer this common questions basically here, right? So this is one thing you can do on the MATLAB. Then maybe I take this. This is a 2-minute video basically where they've shown how.
In times of a disaster, every second counts. MathWorks has a vision for working smarter in those seconds. This is the story of a new smart emergency response system based on MATLAB and Simulink. It represents a paradigm shift in the way we respond to emergencies. Cyber-physical systems are used to help first responders save more lives. The heart of the new emergency response system is Mission Control, which is built with MATLAB. Mission Control receives help requests and surveillance data from the disaster scene. Vast amounts of data streaming from smartphone apps, video cameras, and sensors on rescue dogs and drone aircraft, road and geo maps, as well as authorities on the scene. The system uses advanced optimization algorithms and high-performance computing to run millions of possible rescue scenarios. It creates the most efficient mission plan in seconds, constantly adjusting as new data comes in. The system connects to a fleet of autonomous vehicles. It sends the mission plan, a set of commands, and an optimal path with waypoints to each vehicle. Fixed-wing aircraft that fly reconnaissance sorties, quadcopters that deliver medical supplies and rescue tools, and ground vehicles that set up supply deployment stations and ad hoc Wi-Fi access points. These vehicles monitor the field and quickly respond to requests. They're able to run critical missions safely and reliably by using control and guidance software designed in Simulink. These vehicles are simulated in real time in a virtual world to prove they can operate reliably in disaster scenarios like an earthquake. Back at Mission Control, images from video streams are analyzed with advanced face recognition algorithms. Facial features are compared against those in an authorized database to find matches. Rescuers can notify families faster when a loved one is found. The new smart emergency response system would be a huge technical leap forward, one that would connect first responders and smart systems through a powerful mission control center to find optimal solutions for better recovery goals. It's a perfect combination of technology and human interaction for actionable intelligence that can save time and, more importantly, save lives in times of emergency. The technology exists today, and it's part of a vision of Smart America. Learn more at mathworks.com.
Okay. So this was the, I think you are able to see the video, or it was visible or not? I don't know.
Yes, sir, it was visible.
Okay, so this was one of the way basically how CPS can help, and these all things are simulated on the MATLAB. So then this paper I don't want to discuss. This is one presentation which is available on the MATLAB side basically. Again, it is how SimScape supports the innovation for the cyber physical systems. So they discuss that how the SimScape, you can see here the whole system has been modeled.
मैकेनिकल पे एक बार दिखा लेना, वो दोनों रूम बंद हो गए थे, हो गए.
So you can see the whole system. It is showing. So the car body, then wheels, transmissions, motors, DC to DC converter, battery, cooling systems, generators, engine, all the things are right. And similarly, other places also. Some examples they had shown basically that how we can use SimScape for the modeling of the CPS based systems. Right. So you can also go through that. And yeah. This is the website address actually, if you see Sim events modeling cyber physical systems.html. So there they discuss that how you will be modeling the system. So this is the documentation, then this is the example. Some examples they discussed, right? Modeling the cyber physical systems here, right? Then this it is not related to this actually. Right? So you can go to the MATLAB site and you will get number of such systems available, or you can model them. So this is the example. You can make your own program and then you can integrate it with your system, and then you will maybe getting some data like this, that what is the passenger count, what is the conveyor belt response, and other things, right? Okay. So this was about the MATLAB tool for this. Other than this, if you wish more tools to be added, so let me just take you to some more information related to this. This is a paper, Harrison et al. That is the engineering methods and tool for the cyber physical automation system. it is published in the IEEE proceedings in 2016. So if you see there, this paper discusses that for end-to-end engineering, you can use the automation ML, AML in brief. I will be taking some more details of this. Then pro-step, IVIP, ECL at SS. These are the tools you can use for the end-to-end engineering condition. For communication, you can use the OPC UA, which is based on the IEC 62541 standard. Information layer, you can have the electronic device description and field device tool, FDT and EDT. These are the tools available to you. In the approach for implementation of a functional and information layer, field devices integration. So this will be giving you the integration of the functions and information layer basically. So how the field devices will be integrated with the other layers basically. Right? You may be aware that you will be having some architecture like this. This is the architecture, Industry 4.0 standard architecture taken from this. So here you have the.
Sir, your
Yeah.
slides are not visible, sir. I think you are not shared your.
Just I will just.
It was visible earlier, but now it is not.
Okay. Just I will. Now it is available.
Yes, sir, yes, sir. We can.
So this I discussed. Basically, these are the tools available to you. Then, if you see this architecture here, it is divided into three parts. Basically, the layers. You have the asset level layer. You have the integration layer, communication layer, information layer, function layer, and business layers. Then for life cycle and value stream, there is IEC 62890 standard, and for hierarchy level, there is a standard like 62264 and 61512. So if I see the hierarchy level, we have the product, field devices, control devices, stations, work centers, enterprise, and connected world. So there are different, for example, for the control system integration, you have this standard, IEC 62264. For life cycle and value stream, this standard is there. RAM I.4.0 has been put forward for the Industry 4.0 integration. For PLC, you have this standard. So in order to standardize the systems, we can use this. Right? So several industry standards are, but the main problem is that suppose we use OMG, SysML or this, they are not very formal, means they are specific to a particular system only. Right? So lacking unambiguous definition of syntax and semantics. Right? So different vendors interpret the standards differently. And they use their own serialization formats and implement vendor-specific extensions. Right? So in order to overcome this problem, some precise definite semantics have been proposed like Modelica, FMI, functional mockup interface, and very high-speed integrated circuit hardware description like VHDL, MS, etc. And then we can divide the whole CPS into different parts. So first part is the component and model based system where we can use the UML or SysML is the modeling approach. Right? So these are basically the modeling mechatronic components structurally based on practical experience. So if you see the UML and SML, basically the UML is the used for the software engineer to visualize the software system, and SysML is the extension of the UML for use in the system engineering applications. If you want more details about UML and SysML, you can go to this website. There it has been explained basically what is the difference. For a brief introduction you will be getting. Right? So this is at the component level basically, right? First step was the component and model based system. Then we have to program it. So component programming and deployment, there are different standards which has been done. So for example, IC 61131 or can be used for the abstraction level. View 1 system is also proposed by one. I will be showing if time permits. Time is not there, but in this paper they discuss the view 1 system for the modeling of the CPS basically, right? Then engineering methods and communications. So CPS involves the highly networked system, IT system and automation. So for realizing such an automation network, the question arises how this communication is provided with higher interoperability. So this is the architecture you can have, which has been proposed for this integration. At the base level, you can have the input-output devices. It can be sensors, it can be the actuators. Then PLC or microcontroller can be there. So this is the, we see it is also known as the 5C devices. So this is the component layer. This is the communication layer. Then SCADA is the high level where we will be integrating the systems, and then manufacturing execution system where it will be information will be flowing, and finally to the top management ERP. So this is the vertical architecture which has been proposed for the data linking or the information flow in case of the traditional manufacturing systems. In CPS, we are talking about this type of systems where this ERP, it is talking to the MES also, it is talking to the SCADA also, it is talking to the input-output devices also. Similarly, at MES, it is talking to the ERP, it is talking to the SCADA, it is talking to the other systems also, right? So device profile for web service, OPC UA, and REST. These are the three of the emerging technology for realizing web service enabled device connectivity. So DPWS, OPC UA, and REST. These are the device level connectivity for the, these are the services provided for this basically. Then in addition, you have this SORATs, SODA and IMC, so projects which are using these web services, right? And if you refer these references, you will be getting more information about this basically, right? Then at the interoperability and information models, data exchange is required. So human-machine interface is required, which includes the PLC programming. You may be using the Arduino-based programming, so Raspberry Pi, C, so C, C++ also, and nowadays Python is one of the most popular programming language, basically easy to understand, and you can easily write the programs in the Python program. Right? Sorry, I was disconnected. So at what stage I was there when this disconnection was?
Just
Sir,
one
Python.
Python.
Okay, so you can use the Python also for this purpose, right? Okay. So AML automation ML is basically the combination of existing standard data formats, and then you can use it for the CAEX, can be used in the top level format. Collada is used for the storage of geometric and kinematic information. PLC OML XML is served for the storage of the control logics. So these are the some of the tools, basically software tools you can use, right? And then it can be done. Similarly, simulation and modeling, we are aware of the CAD softwares like ANSYS, CATIA, SolidWorks, so we can simulate them, right? Okay. So in the paper, they discussed basically that how to interfere. So if you see this diagram, Industry 4.0 oriented descriptive framework for CPS engineering environment. So level 0 is IIoT devices, shop floor devices basically. Level 1 is the interface to physical systems, so which includes the PLC, sensors, readers, tools, etc. Then there are data models. So you have the different data models, how the data will be communicated. Then network of tools, networking, and finally network of the organization, which may include the mechanical, control, layout, process, any other things. So these are the physical level, and then we have the cyber physical gap at the building to build stage, and then we convert it to the CPS operation. So when operation comes, we have the ERP, SCADA, or FIS-based systems, which can be used for the training, inventories, monitoring, production management, maintenance, etc. Right? So I'm not going into much detail of that because we are overshooting the problem. And then they discuss the view 1 engineering environment. So this is the environment in which you can build your whole CPS system. This is the design stage, this is the operation system, and this is the building stage. So with the view 1, you can integrate the design and operation, and you can build all this. So view 1 common data model and V library helps in that. So this is the view library, right? So that includes the control deployment and other things, right? This is. And then they presented a case study based on the ASW, basically automation system workbench, which is installed in the Warwick Manufacturing Group at the University of Warwick, UK. So here it is showing the ASW, which is having the modular and reconfigured systems. You can replan the systems physically as well as virtually also, right? And then they included the control systems like Siemens, Bosch, all type of control systems, whatever is possible. They try to collect them. They try to integrate it in this open view, and then they analyze this. So this is how the modeling of a gripper is done. You can see the CAD drawing, and then you can see the 3D animated drawing of the gripper here, right? And you see, this is the control logic they developed using this. So gripper open, gripper closed, gripper open finished. Likewise, you can build the whole sequence of operations about the gripper. Right? Then this is the virtual main and virtual robotic component, so that the human and main Industry 5.0, which is focused on the basically the interaction of the human with the machine. So this is one example where human and the machines, they will be interacting. So this example they developed some simulations on this basis. So this is the human being, this is the machines, and then how they will be interfacing with each other, right? And to control all this, user interface is deployed. Functional blocks have been deployed. Right? And this system is built such that the PLC code and HMI screens are auto-generated. So you can see the sports are generated here basically. Right? And then this is one application where the fault was tracked on the mobile application. So mobile application shows that at this place there is some fault is there, and then you can remotely see it. You can remotely control how to overcome the problem. You can remotely do that. So that becomes the true CPS application basically, right? How we can do. On the net, if you search, there will be more such papers and more such. Maybe I can show you one more paper. Just show you the one more. Let me just. I will take one more minute or two more. Basically. So. This is one paper, open source language and methods for cyber physical systems deployment, overview and case study. So it also discusses some tools for them, basically. We approach and then realization how this will be done. And so you can go through this, how to code, how to integrate, all the things are given in this also. They've shown some animation basically in some, right? Okay. So with this, I end the today's lab session basically. If you have any questions, you can ask me and then we can end that. In between, just turn on your videos also so we can have the one screenshot. Any questions, anything you want to ask? Okay, thank you. So, if no further questions, we end today's session. There is a 2 days break in between. So, what I request you is that you can just revise the things, try to explore more tools, because in the next lab sessions, what we will be doing is that we will be introducing MATLAB, because some of you will not be knowing the MATLAB. So we will be introducing the MATLAB. We will be introducing you how to do the programming, CNN programming or deep learning programming with the Python. Some information related to that. That is what we have planned in the next lab sessions, 2 lab sessions. Then one hardware demonstration. So next 3 days we will be covering in the lab sessions these aspects. So I hope you will be enjoying. And in between, you can we had given an idea about that, how you can use the different softwares in that. You can explore more. Particularly the MATLAB, if you are having, then you have the number of tools available to you. You can explore them, right? Okay. So thank you very much for joining the session. And I end this meeting then. If you have any questions, you can ask. Otherwise, I will.